So for today's lesson, we're going to talk about going backwards with trig functions. So we're doing the inverses of trig functions. What that means is instead of me giving you an angle or my giving you an angle, we are going to be giving you the answer already, and you have to come up with the angle that gives us that answer. So like sine inverse of 1/2, which angle gives us a sine value of 1/2? Now, there are some restrictions, though, that you have to be made aware of when it comes to inverse trig. When you evaluate an inverse trig, there's a very set range that we are allowed to have our answers fall under. And that has to do with the domain of the function. If you look at sine, for instance, currently sine is a function because it passes the vertical line test, but it is not a one-to-one function, meaning the inverse of it will not be a function because it does not pass the horizontal line test. For that reason, we restrict it so that we get a segment that covers every single possible sine value while still giving us a one-to-one function. If you look at this range right here, right along here, I'm going to highlight it. Notice that we have every value from -1 to +1, and none of the values repeat themselves. So for that reason, they use the domain of -π² to π² for sine, or for the inverse of sine, that is the range of our answers. Okay. So we've got to come up with what possible angles we're allowed to use when we evaluate sine, cosine, tangent, and everything based on the graph like I just showed. So for cosine, kind of the same idea. We want something that looks similar to that portion I just drew in red. And you'll notice between 0 and pi, we've got it. It's just, it's the other half of it, but it still is going from -1 to +1. It's still 1 to 1. And this domain right here is 0 to pi. So when we do the inverse, we use the range of 0 to pi. Now, every single one of these after sine and cosine will either follow the sine's trend or cosine's trend, okay? So tangent, for tangent and cotangent, we like to pick a section that does not include an asymptote, or at least is between the asymptotes. For tangent, we use that full curve right here, which is from -π/2 to +π/2, just like sine. And cotangent, I'm going to skip to cotangent since I was just talking about that. Same idea, I want the full curve between asymptotes. So that one's going to be between 0 and pi, if you look at this range right here, or that domain I should say. Now secant and cosecant, we're not going between asymptotes because if we did, we would miss a whole half of the graph. So like for instance, if I just took this portion from 0 to pi, it won't pass the vertical or the horizontal line test. So instead, I am going to take the section from -π² to π², so it does pass the horizontal line test. So this one's -π² to π², just like sine. And then same idea with secant. If I went from -π² to π², this graph in the middle here would not pass the horizontal line test. So that's a problem. So instead, I'm going to take this little section right here from 0 to pi, just like cosine. Wow, that looks ugly. And that would be the portion we use. Now, I want to show you on the unit circle what I'm referring to. So on the unit circle, that's what these, on my unit circle, some of you might not have one like that. But if you did, I like to have that in there, and I like to write out which ones go between 0 and pi. So you'll notice that cosine inverse, we've got secant inverse, and then also cotangent inverse went between 0 and pi. Now on my unit circle, I like to label this as -π/2. This one is -π3, this one is -π4, and -π6, because we're going to be using the negative angles when we use the fourth quadrant. And to remind ourselves which ones use the fourth quadrant, I like to write in that this is sine, or our inverse of sine, we've got our inverse of tangent, so all the other ones, oh, that's hard to read. Inverse of tangent, and inverse of cosecant. Just a note, you'll see it written two different ways. Cosine inverse is the same thing as arc cosine. So if you see that, they mean the exact same thing. They both represent the inverse of that function. So I'll sometimes interchange that terminology. So even if I write it out as cosine inverse or the inverse of cosine, I might say arc cosine. I actually like to say arc cosine better than I like to say the inverse of cosine. So let's go ahead and do that. So once again, like all of these could also be referred to as arc. So like this one could be referred to as arc sine. This one's arc cosine, arc cosecant, and so on. You just put an arc in front. And honestly, you literally just write arc and then you write the rest of it. So let's go ahead and see how this works. I made this little diagram once again because if you notice, for all of them, if your answer is positive, if you get a positive value, it's always going to be in the first quadrant. If the value inside is negative, then it switches to either the second or fourth quadrant. We never use the third quadrant when we're evaluating inverse trig. So, and just a reminder, the fourth quadrant will be used if you are doing arc sine, arc cosecant, and arc tangent. Oops. And then the others, so arc cosine, arc secant, and arc cotangent. All right, so we're going to go ahead and work on our inverses. One other side note to help you remember which one's which. You'll notice that ones that are all primarily y values are going to be using the fourth quadrant because sine is y, right? Cosecant is 1 over y. Tangent, the top is a y, so the top number is a y. So that's how I remember it. While the ones that are using x's are going to be in the second quadrant. And that's because x's are negative in the second quadrant, while y's are negative in the fourth quadrant. Okay? So that might help you know which one's which. Okay, so regardless, if you see a positive number inside the parentheses right here, that's going to tell you automatically it has to be in the first quadrant. That's why I put a little plus sign right here. Okay, so I am going to be looking in the first quadrant, just as a reminder. That's not our answer, so I shouldn't box that. So I'm looking in the first quadrant, and sine is our y value. So if I go into the first quadrant and I look for, wow, this is very grainy. But if you look for the y value of 1/2, that's going to tell you what angle. So 1/2 is right here, which you can look on your own unit circle. So we get pi over 6 as our angle, and that's our answer. So next one, we're doing the inverse of cosine. Once again, this is positive. And if it's positive, that tells me it's in the first quadrant. So I go to the first quadrant. I'm looking, cosine is typically your x, well it is. It's your x value on the unit circle. So I find an x value of square root of 3 over 2, and it just so happens to be the exact same angle we just looked at. So I just go ahead and say my answer is pi over 6. So then we go to our tangent one. This is when things get a little more interesting. So this tangent problem is negative, and when it's negative, you have to figure out if you're using the second or fourth quadrant. Well, in this case, since it's tangent, arctangent, or the inverse of tangent, we are going to be using the fourth quadrant since it's primarily a y, because it's y over x, and y values are negative in the fourth quadrant. So it's y over x, right? So we've got to figure out which of these coordinates right here are going to give us a -1. Well, when you divide them, which of them will give you -1? So if you get -1, that means they have to be, oops, nope, I was right. They have to be the exact same coordinate, just one of them is negative. Okay, so that's right here. I know it's hard to read. Now you have to be careful. In the fourth quadrant, I suggested that you write down your angles as negative angles because you have to have your answer written as a negative angle because it has to be between negative half of a pi and positive half of a pi. So you cannot say that the tangent inverse of -1 is 7 pi fourths. That's considered wrong. You get the whole problem wrong. It has to be negative pi fourths as your answer. Okay, let's go to cosecant. Can a blind man see a sign? Cosecant, just in case you don't remember the trick. So cosecant is the reciprocal of sine. So, and it's positive inside here, so it's a +2, meaning we're going to go to the first quadrant. And in the first quadrant, so it's the reciprocal of sine, so the reciprocal of the y value. So the reciprocal of 2 is 1/2, so we're looking for a y value that is 1/2, which is at pi 6. So our answer is pi 6. Okay, let's go to cotangent. We've got our arc cotangent of -√3. It is negative. So since it's negative, we've got to figure out if we're in the second or fourth. Cotangent has the x on top, and x's are in the second quadrant. So we're going to use second quadrant, so just right here. And then I'm going to go ahead and cotangent we know is x over y, and we want x over y to equal -√3. So in order for that to work, the square root would have to be on top, because then when we simplify, the 2's will cancel and you just get to -√3 over 1, or just -√3. Okay, so if the x is -√3 and the y is 1/2, then we've got to be using the angle 5 pi over 6. And as you keep practicing these will get faster, by the way. Let's go ahead and do another one. We're doing secant. That's the reciprocal of cosine, so that means our x has to be the reciprocal of -2, or -1/2. And since it's negative, we're going to be going to, according to this over here, the second quadrant. That's because it's x values. Remember, x values are in the second quadrant. So we're looking for an x value of -1/2. You can't read my graph very well, but that would be that angle right after pi halves. So our answer is 2 pi thirds.